Brooke Taylor was born in the late 1600s to parents of the English aristocracy. Educated in London, Taylor took an interest in mathematics and science from an early age. At the young age of 23, Taylor published a groundbreaking work in physics. This work at the time solved the modern-day problem with the vibration of strings. From the notoriety he received, Taylor was elected into the Royal Society of London. This picture is a famous picture of Taylor showing this work right after he was elected into the Royal Society, whose members included Sir Isaac Newton, who became Taylor's close personal friend. After being elected into the Royal Society, Taylor got involved in an argument who developed calculus. Newton and a man named William Leibniz were arguing over the development of calculus. The Royal Society got involved, and Taylor sided with his friend Newton as well as the Royal Society. Outside of London, Taylor drew a lot of criticism for this conflict of interest and became unpopular among mathematicians and scientists outside of London. After the dispute was settled, Taylor published his work on perspective. This work had to do with a point called a focal point, where three-dimensional drawings could be produced on two-dimensional surfaces. Taylor proved this point existed in any piece of work. The focal point is used in art throughout history in order to give a three-dimensional illusion on a two-dimensional surface. After he published Perspective, Taylor became involved in a bitter dispute with Bernoulli over the development of Taylor series. This dispute caused Taylor so much grief that he decided to stop working on mathematics at the young age of 34, and unbeknownst to him, he died a couple of years later, leaving behind only one daughter named Elizabeth. Taylor's most significant contribution is called Taylor series. Taylor series is a process that allows mathematicians to evaluate difficult functions. Taylor called these transcendental functions, such as y equals sine x, y equals cosine x, y equals log x, with the nth derivatives of polynomial functions. In this picture on the slide, we have the curve y equals sine x. We also have the curve y equals x graphed. And then we have a polynomial function here in blue that's graphed. And you'll notice that the polynomial function has the same ordinates as y equals sine x from x equals -4 to x equals 4. Through these graphs, Taylor realized that he could evaluate the transcendental function y equals sine x by evaluating the derivatives of the polynomial function at certain points. This process of evaluating transcendental functions using the nth derivative of polynomials is called Taylor series. The applications of Taylor series are immense. First of all, our modern-day calculators are programmed with Taylor series in them. When a calculus student wants to find the sine of 28 degrees, they enter sine 28 degrees equals on the calculator, and they are given a long decimal approximation of the sine of 28 degrees. Of course, this value is between 0 and 1, but what the student does not know is that the calculator has been programmed to use Taylor series to find this value. What the calculator is doing is it's using the nth derivative of a polynomial called a Taylor series in order to evaluate the sine of 28 degrees. This is also why we get an approximation of the sine 28 degrees. We get an irrational decimal for that answer. Also, scientists are able to simulate nonlinear water movements using trig functions, and they can evaluate these functions using Taylor series. Finally, Taylor series makes differentiation and integration easier because we can integrate and differentiate difficult functions by substituting in a polynomial function, which we all know requires just the power rule to differentiate or integrate, which is simple to do. Taylor series is widely used today and is a major contribution to mathematics.